Now let us see how this problem can be solved dynamically. Let us consider this example again. Over here I am having a string x and y. For x I have taken the variable I, and for y I have taken a variable of j. From the first formula, you can see that if the value of I is 0 or j is 0, we are going to straightly put 0 for it. So we'll consider this rows for I and columns for j. So the value over here becomes 0 for I equals to 0 and 0 for j equals to 0. Let us start for I equals to 1. When I equals to 1 and j equals to 1, a is not equals to b. So we have to take the maximum value of either I comma j minus 1 or I minus 1 comma j. This becomes the maximum value of 1 comma 0 or 0 comma 1. So you can notice that whenever I'm going to find the element, and if my element does not matches in both the string, then I'm going to consider the values that are either left of it or at the top of it, and we're going to take the maximum value. So maximum of 0 and 0 is 0, so I'm going to put 0 over here. Then let us consider for j equals to 2. Now you can see that my a matches with my a. See, I equals to a and j equals to a. It matches. So the formula says, take the value of LCS I minus 1 comma j minus 1 and update 1 to it. So this becomes LCS of 0 comma 1. So over here you can see that 0 comma 1 is this element. I'm going to add 1 to it. So this becomes 1. Similarly, let us quickly do it for the other elements. When I is equals to 1 and j is equals to 3, since they are similar, we are going to add 1 to the diagonal element. Similarly, for j equals to 4, a and b do not match. So we are going to see maximum of both these elements. This is 1, so I will be entering 1 over here. For I equals to 1 and j equals to 5, I can see both the elements matches. So I can say that add 1 to the diagonal element. So this is 1 over here. For I equals to 2, I'm having element p. Now I have to check for j equals to 1 to 5. So for j equals to 1, b and b matches. So with the diagonal element, I'm going to add 1. So the answer becomes 1. Next element is a. This does not match. So we are going to consider the right element and the top element, whichever is maximum. So I'm going to say that I got 1 from here. Then I'm going to see again b and a. B and A does not match. Again, I'm going to see those elements and we can say that maximum this is 1 and I'm going to take the horizontal element. Then you can see B and B matches. Then we are going to add 1 to the diagonal element. So I'm getting 2 from here. Again, B and A does not match. So I can say the maximum of both these elements. So I'm getting 2 from here. Now let us check for I equals to 3. You can see that B and B matches, so I'm going to add 1 to the diagonal element. B and A does not match, so I'm going to compare these two elements and will say that I have taken the maximum of both. Then I'm again going to check for B and A, it does not match. Then I'm again going to check the maximum of both, it is 1, so I'm going to consider the horizontal one. Then B and B matches, I'm going to add 1 to the diagonal element. Then B and A does not match, so I'm going to take the maximum of both. Since 2 is the element, then we are going to consider 2 from the horizontal side. Now let us consider for I equals to 4. We are going to check for j equals to 1 to 5. Now we can see that A and B does not match, so we are going to take the maximum of both the elements. Now please note, in such a condition where you are having the same element in both the left element and the top element, you are going to consider the same element, but you are going to mark it as an horizontal arrow according to the algorithm that has been used. Now, since you can see that I'm getting this 1 from my top element, I'm going to mark this 1 with a downward arrow. Then let us consider another element for j. A and E matches, so I'm going to add 1 to the diagonal element. This becomes 2. Then again A and E matches, I'm going to add 1 to the diagonal element. It becomes 2. Then A and B does not match. I'm going to take the maximum of both the values. Since both the values are same, I'm going to consider the value from the horizontal side and then I'll be updating it as 2. Then B and B again matches. So I'm going to add 1 to the diagonal element. Now let us consider for I equals to 5. B and B matches. So I can say that I would be adding 1 to the diagonal element. B and A does not match. So from both of them, 2 is the maximum. And I have taken this from the top row. Then B and A does not match. Again, from this and this, I'm going to take the maximum element. So I'm going to consider 2 from the horizontal one. Then B and B matches. So I'm going to add 1 to the diagonal element. Then again, B and A does not match. So I'm going to take the maximum of both. Since I'm having 3 in both the cells, I'm going to consider 3 from the horizontal cell. Now, after the completion of this, just put the arrows at the topmost position for all the elements that you are getting. In this table, we can see that the maximum subsequence length we will be getting is equals to 3. And we are going to traverse this table along with the arrows to get the subsequence. So moving from the end, we can see that over here I'm getting a 3 and then I'm moving upwards, I'm getting a 2. Then I move upwards, the same value is there in the in the left hand side. So I'm going to take this value 1 and then I'm going to move upwards where I'm getting 0. So the longest subsequence that I'm getting is at the third position, then at the fourth position, and then at the fifth position. So this becomes B, A, and B. For time complexity, we can say that we are going to compare n elements of X string and Y string n element. So the total time complexity can be n square. Or you can say that since the matrix is a two-dimensional and we have to store the elements in it, so the time complexity can again be n into n, which is equals to n square. So in both the ways, you can say that the time complexity for LCS is order of n square.